The world from space to Apollo 10, a globe of jewels set against a background of black velvet and the stars. Man draws life from the sun, but he venerates the moon. 250,000 miles away, to poets, the unattainable woman. But now she's within the reach of man, and the only astronauts to see her saw her as dirty beach sand with a lot of footprints on it. So this dress rehearsal, the final step before man realizes the impossible, a dream as old as man himself, to reach the unreachable star.
This is a CBS News special report, the flight of Apollo 10. Tonight, a close-up look at the dress rehearsal for man's arrival on the moon. Brought to you by Western Electric, manufacturing and supply unit of the Bell System. Reporting now from the CBS News Apollo headquarters, Kennedy Space Center, correspondent Walter Cronkite.
Good evening. Every time there is another Apollo mission, we say that it is the most demanding yet, because every time there's another Apollo mission, that happens to be true. Each mission is planned as another step toward the ultimate goal of landing a man on the moon. To those on the outside, each mission is an heroic adventure, demanding man's courage and his curiosity, and that happens to be true too. But like all great adventures, each mission counts on scientific techniques and complicated hardware. Apollo 10, counting down tonight for a launch on Sunday afternoon, marks the first time that the complete Apollo spacecraft will operate around the moon. And the mission's going to go like this. After that launch, Sunday afternoon, the spacecraft will go into a 115-mile orbit around the Earth. On the second orbit, over on the far side from where I am, over the Pacific Ocean, the third stage of the great Saturn rocket will propel it an extra 10,000 feet per second to a speed of 25,000 miles an hour to escape Earth's gravity. And out here at about 10,000 miles, the command module will separate, turn around, withdraw the lunar excursion module from the third stage, and then they'll be on their own on this long trip, 235,000 miles out to the moon. They'll reach there 3 days later, on Wednesday. They'll go into orbit 69 miles around the moon for 1 day. And then on Thursday, Tom Stafford and Eugene Cernan will climb out of the command module, leaving it, now called Charlie Brown, behind with John Young. They, in the lunar module called Snoopy, will circle the moon twice, and they'll come down within 10 miles of the moon's surface, within 50,000 feet, over the landing site, where if all goes well on this mission, man will land on the moon in July. After two orbits of the moon, they will come back up 69 miles high and rejoin Charlie Brown, John Young, in the command module. And then, after another day of circling the moon, the service propulsion system engine will have to fire on Saturday to send them back on the way home. They'll come back this long trip back to Earth, come directly into the Earth's atmosphere at 25,000 miles an hour, and land just east of the American Samoan Islands, 400 miles east of Pago Pago. The lunar excursion module is built by the Grumman Aircraft Engineering Corporation of Bethpage, Long Island, and Nelson Benton is there.
The lunar module is not as small as you might expect. It is nearly 23 feet from the base of its spraddle-leg landing gear to its top. On Earth, it weighs about 15 tons. It is not a picture of aerodynamic grace, but aerodynamics play no role in the atmospheric void around the moon when Stafford and Cernan take the LEM down to within 50,000 feet of the lunar surface. 50,000 feet is only slightly higher than you might fly on a commercial jet flying from coast to coast. But flying above the moon is different. There must be protection from the extreme heat and from the extreme cold. That is why the reflecting blankets, as they are called, colorfully surround the lunar module. Engineers here at Grumman are interested specifically in how the landing radar performs on this, its first flight. But overall, they are interested in the LEM's performance in this, its first venture into the lunar sphere of influence, the environment for which this vehicle was so painstakingly designed and built. Walter?
We'll look at the crew of Apollo 10 in a moment. There are now 51 American astronauts, but for the next 10 days, attention will focus on 3 of them, Stafford, Young, and Cernan. Recently, David Shoemaker asked them to talk about each other.
Right. Well, We think it's the most experienced crew they've ever put together. But, John Young's had 2 flights, I've had 2 flights, and Gene has had 1. There was a total of 11 rendezvous on the Gemini program. I flew 4 of the rendezvous, and John flew 2, so between the 2 of us, you have 60% of the rendezvous. And as far as command module simulator time, nobody in the world can touch John Young for total time.
Now tell me about John Young. He's a pretty quiet fellow.
Well, John is not all that quiet. John is very subtle in humor, but if you know John like I know him, you know him as a very capable individual, a very likable individual, an individual that Tom and myself, well, Tom had worked with John before, I never had, but an individual different than Tom, and Tom is different than me. In other words, we're 3 distinct people. I think that's why we get along so well. I think that's why we've been able to develop the confidence in each other that we have over the past 2 years. And to fly a mission like this, you've got to not only understand the other 2 guys, but you got to have a great deal of confidence in them, because the mission, the success, the failure, your life is in each other's hands.
Well, how bad is it to spend 4 or 5 or 8 days cooped up with Tom Stafford and Eugene Cernan?
I've been thinking about that a great deal. It's okay, except when Gene starts singing. Then you wish you could go on the limb.
2 of the men who've been involved with the Apollo program from blueprint to reality. Krupp at North American Rockwell in Downey, California, and Scott McLeod at Grumman Aircraft in Bethpage, Long Island. Gentlemen, you've been test pilots for a long time now. What's flying this Apollo 10 mission going to be like?
Well, Walter, I guess that in the LEM specifically, what we've done is combine the best characteristics of a jet aircraft and a helicopter. We've retained the responsiveness and the flight characteristics of a jet, and in addition have added the additional degrees of freedom that you get from a helicopter in being able to translate independently along each one of the 3 axes.
Walter, the command module flies exactly like the lunar module. In fact, the controls and the displays are very similar, and this was purposely designed that way by the NASA so they would minimize the pilot training in going from one vehicle to the other, and when the crew left the command module to go into the lunar module, they would be in familiar surroundings with the same type of controls and the same pilot techniques involved in controlling the spacecraft.
I understand this time they're planning on taking some spoon-sized food with them instead of using the squeeze bags this time. Are you planning on the same thing in the command module as the lunar module as far as food goes?
Well, that's right. As a matter of fact, they did take some of that food along on Apollo 9 to try it out. The whole food problem is sort of up for grabs right now. The astronauts, being big, healthy, active boys, really would like to eat a little bit better than they have been on these past flights, and there's a very accelerated program going on trying to improve the quality of the food and also the enticitiveness of the food, so it appears a little bit better to the crew rather than squeezing it out of a bag like toothpaste into your mouth. We would like to give them a little better menu.
Good night, Leo.
Okay, see you later, Scott.
Although the final countdown continues on schedule, the space agency here announced tonight a pressure drop in the system used to control the spacecraft in flight. And technicians are checking out this potentially serious problem in Apollo 10, but the countdown continues. We'll be back with a preview of what could give us a new look at the universe in a moment. Tom Stafford believes that it is vitally important to share the fantastic views of outer space with those of us who are earthbound. So he has urged the development of color television from space for the first time, and he's committed his crew to hours of televised reports to Earth. Bill Stout reports from North American Rockwell.
One of the firsts in Apollo 10 will be color television, pictures transmitted from outer space. How good is this camera, Leo?
Well, Bill, during our ground test, the reception from this camera has been outstanding, and we hope that on this flight it'll function properly and we can send back some terrific color shots from outer space.
11 transmissions are scheduled, all in color, but we do have this as a backup.
Yes, we're carrying the black and white camera along as a backup in case the color camera should malfunction. Now, this is the black and white camera we've carried on previous flights, and this is the color camera. And you can see by comparing the size that the color camera really isn't very much larger.
Another first is that they're going to have a monitor this time so that the astronauts can actually see the pictures they're sending back to Earth.
Yes, on previous flights we've had difficulty. The crew is unable to accurately point the camera and they had to be coached by the ground. So on this flight we're carrying this black and white monitor which attaches to the camera so the crew at all times can monitor exactly what they're transmitting out of their camera back to Earth.
That way, for instance, they can show us the actual rendezvous and docking with the lunar module.
That's right. This will be shown distance of 10,000 miles from Earth, so we should get terrific shots of both the S4B, the LEM, and the Earth in the background.
And all this emphasis is because the astronauts want to share their experience with the people on the ground. All this and in color, too.
The Apollo program will cost the United States $24 billion. Some argue that this is too much to spend for a nation which faces what they call higher priorities, an unpopular war abroad, a danger of increasing unrest at home. Some scientists say the Apollo program is of little scientific value. Others call it a form of showboating. Some cynics say we are simply carrying out the romantic dream of a martyred president, John Kennedy, who pledged an American man on the moon by 1970. These are all points to be argued. But the moon has held a certain steady fascination for man through the centuries. And in an earthbound way, you could say a man searched for the moon 500 years ago. He was curious to see what was on the other side of the ocean. A nation depleted by war and interior strife, its treasury so low that its ruler pledged her personal income to the venture, invested as much as $75,000 in a man curious to find a passage to India. He failed. His name was Christopher Columbus, and what he found, according to some historians, was America, which turned out to be a discovery of some importance. The trouble with great futures is that mortal man cannot foresee them. This is Walter Cronkite, CBS News, in the Kennedy Space Center. Good night.
This has been a CBS News special report, The Flight of Apollo 10, brought to you by Western Electric, Manufacturing and Supply Unit of the Bell System. CBS News coverage of the flight of Apollo 10 will begin Sunday morning at 11:30 Eastern Time. Be sure you're tuned on CBS. This is a CBS News special report, The Flight of Apollo 10. Dress rehearsal for a landing on the moon. Today, the launching of astronauts Stafford, Young, and Cernan. Brought to you by Western Electric, the manufacturing and supply unit of the Bell System, as part of our continuing coverage of important news events. Reporting from the CBS News Apollo Headquarters, Kennedy Space Center, correspondent Walter Cronkite.
Good morning. The weather is good here at the Kennedy Space Center in Florida. The astronauts are aboard their command module out there on the pad, ready for launch off, and the countdown goes right ahead toward a launch 1 hour, 17 minutes, and 39 seconds from now. This is a Sunday launch, and we've only had one other Sunday launch in the history of 19 flights in the manned space program since the first one back in 1961. And since it is a Sunday morning, and we perhaps have a lot of school children with us in our audience this morning, and perhaps some adults who haven't had the opportunity because they have been at work on weekdays to see a launch, we're going through just a few ABCs here this morning before we get to the last minutes of the countdown. You're going to see on our broadcast before the scheduled launch at 12:49 a.m. or p.m. Eastern Daylight Time. We're going to hear from our correspondent Bill Stout and test engineer Leo Krupp at North American Rockwell in Downey, California, where they build the command module. And we're going to hear from our correspondent Nelson Benton and test engineer Scott McLeod at Grumman Aircraft Engineering Corporation in Bethpage, Long Island, where they build that strange-looking bug called the Lunar Excursion Module. Bruce Morton is at the Manned Spacecraft Center in Houston, Texas, where they control this flight immediately after the launch, which is controlled here at Cape Kennedy. David Shoemaker is in New York to fill us. Weather consultant Gordon Barnes is in New York as well. Here in our Kennedy Space Center news headquarters for this flight, I will have as a guest the distinguished fiction writer and science historian Arthur C. Clarke. Now, let me tell you just a few of the ABCs of this flight. First of all, as you undoubtedly know by now, it is a dress rehearsal for the flight expected to come in July, if all goes well on this flight, putting a man on the surface of the moon for the first time, which has to be one of the greatest stories of civilized man's entire existence on this Earth. The first time he escapes from the Earth and actually lands on another planet. This flight today will take the Apollo spacecraft into 2 orbits around the Earth, and then on its 238,000-mile trip out to the moon. Take it 3 days to get out there. At the moon, it'll go into orbit around the moon for 1 day, and then on Thursday of this coming week, the astronauts Tom Stafford and Eugene Cernan will climb into the lunar excursion module, and they'll go closer to the moon's surface than man has ever been. On that flight of Apollo 8 in December, man's first trip to the moon, they stayed at a 69-mile high altitude, and they had no lunar excursion module with them. But this time, with that little bug landing craft, they'll go down within 10 miles, 50,000 feet of the Earth's surface, of the moon's surface, and take a look at the landing site where the Apollo 11 men are expected to land in July. Now, to do this flight, of course, requires some highly trained men and some very highly complex equipment. The men who will make the flight, which will last a total of 8 days and 4 minutes exactly before they come back to Earth a week from tomorrow on Monday and splash down 400 miles east of Pago Pago in American Samoan Islands out in the southwest Pacific. That's 400 miles east of Pago Pago and 5,200 miles west of Walla Walla. They'll be landing there on Monday afternoon. They'll have spent 2.5 days around the moon, 8 hours in that lunar excursion module. The crew who will do this job are Air Force Colonel Tom Stafford. He's 38 years old. He's a native of Oklahoma and a graduate of Annapolis, although he got into the Air Force after he got out of Annapolis. He has 2 little girls, ages 14 and 11, and he and the children and his wife are going to watch this launch from their home in Houston by television, even as you and I will be. He is a veteran of the flights of Gemini 6 and 9. He is the commander of this flight. Then Navy Commander John Young will be sitting in the middle seat of the 3 seats abreast in the command module. He is the commander of the command module, the pilot of the command module. He's 38 years old also, a native of San Francisco, but he was brought up just 60 miles here from the Cape over in Orlando, Florida. He has a girl 12 and a boy 10. He's a veteran of Gemini Flights 3 and 10. And then over in the right-hand seat is Navy Commander Gene Cernan, who is the pilot of the lunar module. He's 35 years old. He's a native of the Chicago area. He has a little girl 6. And of the astronauts, only his wife and daughter will be here watching the flight from the Cape. He is a veteran of Gemini 9 flight, and if you'll remember on that flight, he made a 2-hour, 10-minute space walk. Now, the equipment that they're going to be riding, well, you're seeing a little bit of it right now. You're seeing the very base of that big Saturn rocket, that picture you just saw, where the great engines fire the Saturn into orbit. And you see a picture there of the Saturn on the pad as the liquid oxygen down at its minus 300 degrees, 293-something degrees temperature is venting off. It steams as it fills into the tanks, and that's what you see in the steam. There are the bells of the 5 engines, which together develop 7.5 million pounds of thrust, which is more thrust than any other rocket cluster in the world. This is the biggest rocket in the world. The Russians haven't come near us in size of rockets as far as we know. The best we know is that they've got a rocket just a little less than half the size of this one, around 3 million pounds thrust instead of 7.5. Looking at this model here, you get an idea of the vast size of that rocket. That picture you're seeing is with a telescopic lens of the rocket actually behind us, but it's almost 5 miles away from us here. But here, right down there, you almost can't see him on this camera, but there is a man, a model of a 6-foot man at the base of that rocket, and you get an idea of how large the rocket is. There he is, 6 feet high. That's the base of the rocket. Now, the rocket is in 3 stages.
one stage, the big stage down here at the bottom, which has to get this 3,000 tons. 3,000 tons this thing weighs. They have to get that into orbit. So that rocket is the big part. It's the 7.5 million pounds thrust. 5 engines down there with 1.5 million pounds of thrust each. Then the second stage, the first stage drops away. The second stage takes over. It has 5 J2 engines, it's called. 1,125,000 thrust total, 225,000 thrust to each of the engines. And then that stage drops away, and this finally goes into orbit around the Earth. This is all taking place while they get up to that 118-mile height where they will orbit the Earth. Then you've got the third stage of the rocket here, and that's got one of those J2 engines, 225,000 pounds thrust, and that will finally put on the second orbit this much into a trajectory toward the moon. At that point, this is dropped off. That's an escape tower, and that thing is 5 times the size, believe it or not, of the first rocket in power that carried Alan Shepard into his suborbital flight just 8 years ago. That's just the escape rocket to pull this command module away if anything should happen on the pad before an explosion could take place, it would be hoped. Now, this goes into the trans-lunar trajectory on the way out to the moon. If I could get it apart here, we'll get this command module out and show you what happens here. This comes apart in this fashion. That is the command module and its service module. The service module has a 20,500-pound thrust engine to do vital maneuvers out around the moon and to bring the men home. As they get out into the trans-lunar trajectory, the fairing falls off here, peels off, blown off actually with some explosives, and the command module turns around, comes back in, links up with the lunar module, which is in its garage here in effect on the third stage of the S-4B, and pulls it out. It's ejected by springs to help pull it out, gets a little distance away, and then they fire this off to go on out around the moon and toward the sun, never to be seen by Earthman again. This goes on then to the moon. When they get out to the moon, they separate on Thursday after 1 day of orbiting, after Stafford and Cernan have climbed down through that little hatch opening there into this lunar module, while Young circles the moon for those 8 hours at 69-mile altitude. This lunar module circles the moon but comes down within 10 miles of that landing site. Then, for the first time in lunar atmosphere, this ascent stage will fire just as they will off the surface of the moon in that July flight and separate. The descent stage will fall behind and go into orbit around the moon. It will remain on the moon in July, go into orbit around the moon, eventually decay and crash into the moon. And this much, the ascent stage of the lunar excursion module returns to the orbiting command module. They join up again. Stafford and Cernan climb back into the command module. They jettison this, throw it away, in other words, rather expensive to do. And then they fire this 20,500-pound engine on next Saturday to come back home. Arrive home on Monday, and when they get into the Earth's atmosphere, just before the Earth's atmosphere, they separate, and just this little bit, the command module, just 12 feet high and 12 feet across, comes back and makes the landing in the Pacific. That's all that comes back of all of this, 363 feet high and 3,000 tons of it, and that's all we get back. That's the flight of the Apollo 10 to prepare the way, to find the landing site, check out the landing site, check out the radar and all the equipment for the first time around the moon in exactly the same time schedule, exactly the same sort of flight as the moon landing, except they won't go to the surface of the moon itself. CBS News color coverage of the flight of Apollo 10 will continue in a moment.
Does this look like a washing machine? Or a toaster? Or a steam iron? Or a refrigerator? Hardly. But some people are still confused about what we make. Western Electric is the manufacturing and supply unit in the Bell system. We're a part of it. What we do make is telephones. And much of what it takes to connect them together, like underground cable. And to send your calls leaping through the air, microwave radio relay systems. And complex equipment that finds the number you dial. Western Electric makes this for your Bell telephone company and the other Bell telephone companies across the land. Because we're with them in the Bell system to help bring you dependable, low-cost communication service. Does this look like a refrigerator?
And it's now 11:44 here in Florida, Eastern Daylight Time. The launch of the Apollo 10 should come in 1 hour and 5 minutes and 24 seconds from now. That's the way the countdown clock is going for this launch this morning. The launch of Apollo 10 is going to inaugurate a new launch pad here on Merritt Island. Pad B, it's called, 39B to be exact. This complex was built here with 2 launch sites, and there's room to add a third if needed. Earlier Saturn V's have lifted off from Pad A, which is directly behind us here. The lunar landing flight this summer, Apollo 11 is going to begin on Pad A there, 3 miles from us. David Shoemaker has a report on why we're using Pad B for Apollo 10.
The decision to use Pad B seems to boil down to one simple fact. It is there. Of course, there is a somewhat more complex bureaucratic explanation involving what are called recycle times, that 2 pads can more quickly handle Apollos 9, 10, and 11. But in fact, Apollo 10 was not rolled out until 9 went into orbit, and 11 won't come out of the huge vehicle assembly building until 10 is launched. So, while one $23 million pad is being used, the other $28 million pad is virtually deserted. Like the explanation for Vietnam, the reason for 2 launch pads has changed over the years, depending partly on the outlook at the time, partly by who is doing the explaining. Originally, the hope was that rockets would be blasting off almost monthly, and sometimes even simultaneously. When Congress failed to get quite that enthused over the space program, officials began to emphasize the safety margin. If a rocket blows up on one pad, it is said, there would be no delay switching to the second. But as we learned in the 1967 fire, which killed 3 astronauts, such tragedies provoke lengthy investigations, and pad damage can be repaired long before a government commission finally finishes its review and okays another launch. And if the argument for 2 pads has any merit, even NASA officials like G. Merritt Preston admit there is a stronger argument for operating off the same pad for every launch.
There are advantages, as I said, because of the constant use, you become familiar with equipment, you understand it, and therefore it is more reliable. And secondly, then if you only use one pad, you have to only maintain one pad. We, of course, would have to do some maintenance on the other, but it's not near the same amount of work.
Not many people ever believed there'd really be a need for 2 launch pads, rockets simultaneously going up from Pad B over there and Pad A here. It was just nice to daydream about. To indulge the daydreamers, however, cost the taxpayers $20 million, an expensive dream, even by space program standards. David Shoemaker, CBS News, Kennedy Space Center, Florida.
David mentioned the explosive power out there, the damage that could be done by an explosion on the pad. These are very critical moments as you look at that Saturn V-B sitting there on the pad. That anything, of course, could happen. All the precautions have been taken, but you've got to realize there are 1 million gallons of explosive fuels aboard that beast out there right now, of liquid oxygen, liquid hydrogen, and of a kerosene-like fuel similar to a jet engine fuel. 1 million gallons of it. And they say that if it were compressed together, it would have an explosive power of 1 million pounds of TNT, at 50 times the Hiroshima bomb. We're 5 miles away at that site you see right there. That's the press site in that picture from the roof of the vehicle assembly building, which is just a few hundred yards over to our backs here. This is the site where the world press watches these launches. Over on the left, a sort of a grandstand for the writing press, and over on the right, the caravans for the broadcasters, radio and television. We're expecting an announcement from Jack King in Mission Control at just about this moment. Let's listen. This is a scene of launch control here at the Kennedy Space Center. That's in the Vehicle Assembly Building just beyond us here. We were told we were going to have this announcement from Jack King. We haven't heard from him yet. He is the one who keeps us in touch with the countdown procedures, and we expect to hear from him now in very few seconds. This complex area over here in the Vehicle Assembly Building and the Launch Control Building adjoining it, where dozens of technicians are each monitoring their own